Hello guys, in this video we are going to discuss the solution of the problem construct binary tree from parent array. So let us look at the problem statement. The problem statement says given an array parent that is used to represent a tree, the array indices 0 based indexing are the values of the tree nodes and parent I denotes the parent node of a particular node. The parent of the root node would always be -1 as there is no parent for the root. Construct the standard linked representation of binary tree from this array representation and return the root node of the constructed tree. Note, if two elements have the same parent, the one that appears first in the array will be the left child and the other is the right child. You don't need to print anything. The driver code will print the level order traversal of return root node to verify the output. So let us try to understand the problem statement with the help of an example. If the parent array which is given to us is this, so this simply means this is 0th node and parent of 0th node is -1, which simply means this is the root node. Similarly, this is my first node or node 1 and parent of node 1 is 0, which simply means parent of node 1 is node 0, and so on for the rest of the cases. And in that way, if we go ahead and construct a binary tree, then this is the binary tree we will be able to construct. And for this problem, we need to return the root of the binary tree. So that's the problem statement, folks. Now let us look at the solution of the problem. So in order to solve this problem, what we are going to do is we are going to take a dictionary, and the key for this dictionary is node number. So 0, 1, 2 or so on. And corresponding to this key, the value will be the node itself. And once we have such a dictionary with us, then we are going to iterate on the parent array which is given to us. And then we are going to manipulate the left and right pointers of the node. And in this way, we will be able to form a binary tree from the parent list which is given to us. So let us take this example. As you can see, the size of the parent array which is given to us is 7. And this is the index which I have populated. So corresponding to index 0, the value is -1. So that simply means node 0 is a root node. And similarly, if you take this node, then this node is 2 and the parent of this node is 0. And so on for other nodes. Now, as per our algorithm, what we are going to do is we are going to create a dictionary. So let us say this is the dictionary which we have. And the key of this dictionary are the indexes or the node numbers. So 0th node number, first node number, second, and so on for others. And corresponding to each of these node, we have the actual node with us. So this is node 0, this is node 1, and so on for the rest of the nodes. And in this way, we will be able to populate our dictionary. Now, initially, the left and right child of each of these nodes is none. So it is not pointing to any other node. In order to manipulate the pointers of these nodes, what we are going to do is we are going to iterate on the parent list which is given to us. So the first node which we see is 0th node. So what we are going to do is we are going to fetch this 0th node from our DP dictionary. So node 0 will come over here. And corresponding to node 1, we will look into parent list in order to find out its parent. So since the parent of node 0 is -1, that simply means that this is our root node. So we are going to take a pointer and set it over here, stating that this is our root node. And then we will move forward. So now the next node is node 1. So again, we are going to fetch node 1 from the DP table. So this is my node 1. And let us fetch it. Corresponding to node 1, the value is 0, or the parent of node 1 is 0. So we are going to take parent of node 1 also, which is node 0, and we are going to put it over here. And once we have parent and node with us, we are going to manipulate the pointers. So as you can see, the left child of node 0 is none. Since the left child of node 0 is none, because of which node 1 will come towards the left of the binary tree. And then we will move forward. So the next node in our list is second node. So we are going to take second node from it. And corresponding to second node, the parent is 0. So second node and parent of second node is what we need. So let's take the second node. So the second node is node 2, and as we can see, the parent of second node is 0, which is already over here. Now since the left child is already occupied, so that simply means that this is the right child of the node 0, because of which we are going to put node 2 on the right child of node 0. Now let us move forward. So the next node is node 3, and we are going to take node 3 from here. Corresponding to node 3, the parent is first node. So node 3 and node 1 is what we are going to need. So let's take node 3, and node 1 is already over here. Now since the left child of node 1 is empty, because of which we are going to place node 3 towards the left child of node 1. Now let's move forward. So the next node is 4, and parent of node 4 is 1. So we would be needing node 4 and node 1. So let's take node 4. Repeating the same logic, as we can see, the right child of node 1 is empty, or rather the left child is already occupied, because of which we are going to place this towards the right child of node 1. So let us do that. Now let's move forward. So the next node is node 5, and the root of this node is 3. So let's take node 5 and node 3. So node 3 is already there, and we are going to extract, or we are going to take node 5. So this is our node 5. And since the left child is empty, so because of which we are going to place it towards the left of node 3. Now the next node is node 6, and the parent of node 6 is node 5. So we will be needing node 6 and node 5. So let's take node 6, node 5, since node 5 is already over here. And since the left child of node 5 is empty, because of which we are going to place it towards the left of the node 5. And in this way, we have constructed our binary tree. And towards the end, all we have to do is return this root which we have initially set. So that's the discussion of solution, folks. Now let us discuss the pseudocode of this problem. So in order to optimize this solution, what we are going to do is we are going to form DP table as well as the manipulation of left and right child at the same time. So let us see how we will be able to do that. So let us say we want to construct a tree, and parent list is given to us. So as we know, we need a DP table for this. So let us say a dictionary DP is what is needed over here, and also a root pointer, so that we could return this root, and initial value of this root is none. Then we are going to iterate on parent list. So let us iterate on parent list. So the first thing which we are going to do is we are going to form a node I. So let us form a node I. So before we go ahead and form node I, we are going to check our DP table in order to see whether node I already exists in DP table or not. So if I in DP, so that simply means node I exists in DP, then we are going to take node I from the DP table. Otherwise, we are going to form a node. So let us form a node. And once I have formed a node, I'm going to put this node in our DP table. So DP of I equals to node. Once we have put node into the DP table, let us see whether this node is our root node or not. So if this is a root node, then parent of I should be equals to -1. If this is the case, then this is the root node, because of which we will just go ahead and say root equals to node. And in this way, we will be able to catch our root node, or we will be able to update our root node. Once we have updated our root node, then we are going to fetch the parent of node. So let us fetch parent of node. So in order to fetch parent node, we are going to see whether parent node exists in the DP table or not. So parent of I in DP. So if parent of I is in DP table, then that simply means parent I node already exists in DP table, because of which we are just going to take our parent node from the DP table. So parent is equals to DP of parent of I. Otherwise, we are going to form a parent node and we are going to push it on through the DP table. So let us do that. Rather elif, and we will just take this precautionary step, parent of I equals to not -1, right? Because this indicates our root node, and -1 node should not be there in the DP table, because of which we are putting this condition. So for this case, we will form a parent node So let us form a parent node. And once we have formed the parent node, we are going to put this parent node in our DP table. So let us define a parent over here, and let us initially set this value of parent equals to none. So from line 10 to 14, it might be possible that parent gets updated or parent remains none itself. So if parent is not none, in such case, we just have to manipulate the left and right child of the parent pointer. So let us manipulate it. So in order to manipulate this, what we are going to do is we are going to put node towards the left of the parent, and if left child is already occupied, then we are going to put it towards the right of parent. So let us check that. If not parent of left, so if parent of left is empty, then the node will come towards the left of parent. So parent dot left is equals to node. Otherwise, we can put this node towards the right of parent. So let us do that. Else parent dot right equals to node. And once this loop ends, we are just going to return root. And in this way, we will be able to form a binary tree from the parent list. So that's the discussion of pseudocode, folks. Now let us see how we have implemented this in Python and C++. So first, let us take a look on the Python implementation. So for Python implementation, we are taking a DP table with us, then a root, and we are setting the initial value of root equals to none. Then we are iterating on the parent list, and we are checking whether node I exists in the DP table or not. If it exists in the DP table, then we are taking node from DP table. Otherwise, we are creating a node and we are putting it into the DP table. If the current node is a root node, then we are updating our root pointer. Once we have updated our root pointer, then we are fetching the parent value. So parent initial value is equals to none. And we are checking whether parent already exists in our DP table. If it already exists in our DP table, then we are taking parent from DP table. Otherwise, we are forming a parent node and we are pushing it onto the DP table. Please note, this is a special case because parent of I equals to -1 represent it is a root node, and -1 node is not a valid node, because of which we are not going to push it on to our DP table. Once we have updated or once we have fetched the DP table, then we are going to manipulate the left and right child of the parent. So if parent exists and its left child is empty, then we are going to place node towards the left of parent. Otherwise, we are going to place node towards the right of parent. And towards the end, we are returning root. So that's the Python code, folks. Now let us submit our solution. So our Python code got accepted. Now let us look at our C++ solution. So our C++ solution is also the same. Over here, I have just taken another function which is create node. And over here, all I am doing is I am creating a node, and then I am setting left and right child equals to none, and then I am returning that node. Now let us look at our main function. So we have a map or a DP table over here, and initially root equals to null. Then we are iterating on the parent list, and we have two variables with us, node and parent. Initial value equals to null. Then we are checking whether node exists in the DP table. If this condition is satisfied, that simply means node does not exist in the DP table, in which case node equals to I am creating a node and then I'm inserting this node in our DP table. Otherwise, we are fetching that node from our DP table. If this node turns out to be the root node, then we are updating our root and then we are fetching our parent pointer. So if the parent pointer does not exist in the DP table, then in such case we are creating a parent pointer and we are putting it into our DP table. Otherwise, we are just fetching parent node from the DP table. And once I have parent and node with us, I'm manipulating the left or right child of the parent. So if parent exists and its left child is empty, then I'm placing node towards the left of parent. Otherwise, I'm placing node towards right of the parent, and towards the end, I'm returning root. So that's the C++ code, folks. Now let us submit our solution. So our C++ solution got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.